We're back here with some binomial trees. These are pretty fun to do. They're a little bit long to fully complete. There's a lot of steps involved, but as so long as you have all the formulas down, you're golden. This will be really easy to do. So basically the first thing when you look for these formulas is you need to understand that there's two different ways of solving them. There's the replicating portfolio method and there's the probability method. I'm not sure if it's called probability method, but basically when you first see the problem, just look for some kind of word or wording or verbiage that implies a stock volatility or probability or standard deviation, something along those lines, some kind of percentile of chance of the stock going up or down. And if that's the case, then you have to use the probability method, which is this long formula down here, which basically is the present value of the predicted payoff of whatever that asset is. Or we're going to have our replicating portfolio, which in this case I have here is going to be our call is equal to our delta of our S of 0. The delta is just the change in option value over the change in stock price, plus B, B being just a zero coupon bond earning money at a risk-free rate. So with this problem here, we have the current price of B and M stock is $60. The stock pays no dividends, and the current continuous compounding risk-free rate is 4% per year. And then at the end of 1 year, the stock will be valued at $72 or $50. And they want us to calculate the price of a 1-year straddle with a strike price of $62.50. And then just a reminder here, a straddle is a one long call and one long put option. So looking through this problem, there's nothing here that represents probability or standard deviation, so we can immediately just cross off this probability method of solving what the call price is. So first I'm just going to kind of get like the extract the important information, just a tiny little bite-sized piece here. We have our stock price at time 0 is 60, interest rate is 4%. We're looking for one long call, one long put, and we know that our time is equal to 1. So we'll start building our tree off here. We have our stock price is $60, and we know that it goes up to and down to 72 or 50. So now we got to figure out what our calls are going to be. What's going to be the payoffs on our call? And we know that a call is just going to be our strike price minus the underlying assets price at time 0 or stock at time 0. That's going to equal 9.5 here. And when it goes down, we're going to have 50 minus 62.50. That's a negative, and the max that the payoff of a call can be is 0, so we just default to 0. So this is going to be our call up value, and this is our call down value. Call up is going to be 9.5, call down is going to be 0. And the next thing we need to determine is our up factor and our down factor. So what we do with this is we go to our stock price here, and we're just looking for what the percent change is between going up and going down. So we just take the price of the stock as it goes when it goes up divided by the base stock, or the price of the stock as it goes down divided by the base stock. So our up factor is 72 over 60, and our down factor is 50 over 60. And then moving forward, we're going to try and find our delta here. So recall we have the delta formula right here. It's the call up, which minus the call down. So our call up here is 9.5, and call down was 0. And then we divide that by our stock price, which was 60. And then, but we have to multiplied by the difference in the up factor and the down factor, which is 72 over 60 minus 50 over 60. And that gives us 9.5 over 22. So that's the first half of this equation finished, or this formula. And then next we need to find our B, our bond. So recall that from this formula right up here, our bond is going to be E to the R8, negative RH. R being our risk-free rate, H being the time period here is just 1 year. And have that multiplied by our up factor, which is 72 over 60, times the payoff when the call goes down, which is 0. Let's just cancel everything out. And minus the down factor, which was 50 over 60, times our payoff when the call goes up, which is 9.5. And we also have to divide by our up factor minus our down factor, which is 72 over 60 minus 50 over 60. And that gives us negative 20.7443. So we put it all together. Our call is equal to our delta, 9.5 divided by 22, times our stock at time 0. And then we're going to add our zero coupon bond, which is negative 20.7443. And that gives us a call price of 5.16479. So long as you have all these formulas down, just these top three, you don't even have to worry about the probability one. For these, with this type of binomial tree problem, you're golden. It's super easy. So we just got to finish this out. So remember, this problem asks for a straddle, which is a long call and a long put at the same strike price. Same strike price. Got to remember put call parity. So we just put that in. Our put call parity formula is a call minus a put equals our underlying asset minus the strike price to the present value with a continuous compounding interest rate, which is e to the negative RT. Just fill in the blanks with our different numbers here, and we get that the put price is 5.214. So that's kind of a nice little shortcut method of finishing this problem instead of redoing all of this stuff back up here for a put price. This just makes it really easy, super simple. And then just combine the two, and we get that the straddle price is 10.379, and that's it.